brought to you by Pieces123.com. I learn and teach online.
Here's the next question, number 34. Suppose x1 of t and x2 of t have the Fourier transforms as shown below. x1 of t corresponding to x1 of omega and x2 of t corresponding to x2 of omega. You should know that the axes are actually j omega. Okay? So, which one of the following statements is true? x1 of t and x2 of t are complex. x1 of t and x into x2 of t are also complex with non-zero imaginary parts. Okay, so basically here all of the options deal with either x1 of t and x2 of t are real or complex, and the multiplication of both is real or not. Okay, let's check it out now. The first thing is notice both the waveforms given to you. The Fourier transforms of x1 of t is x1 of omega, j omega, and the second one is the Fourier transform of x2 of omega. Okay, look at the waveform over here. You will see that if you flip this over, you will arrive at this, right? Okay, so the first thing is, if you flip this over, just flip the right hand side to the left hand side to the right hand side, it's not symmetric. Now because it is not symmetric, it is a complex, it's a complex signal. x1 is a complex signal. I'll write it down over here. x1 of omega and x2 of omega, they are not conjugate symmetric. Now the reason they are not conjugate symmetric is, that's just it. If you just flip the function around, flip the waveform around, you will see that it is not symmetric. If you get the exact same waveform, if you flip it over, then it is known as conjugate symmetric. In mathematical terms, f of minus x should be equal to f of x. When this is obtained, it is conjugate symmetric. Because it is not, f of minus x is not equal to f of x, that is x of here, okay, these two, when they are flipped over, they are not conjugate symmetric. So therefore the signal will not be real. Now because the signal is not real, that tells us, okay, here, I think I'll write it down over here, or better yet, let me get another sheet of paper. If you'll just give me a quick second. Yes, okay. So I'll write it down here, or better yet, underneath the waveforms given to us. Okay, so j1 of omega and x1 of omega and x2 of omega are not conjugate symmetric. Again, I repeat that it is symmetric only when f of minus x is equal to f of x. Only then it is conjugate symmetric. So this means that the signal or the signals x1 of t and x2 of t are not real, and if they are not real, they are obviously complex. x1 of t and x2 of t are complex. So that's the first part. Then the next part is they want to find out about the multiplication. The multiplication of both signals, x1 of t times x2 of t. Now for Fourier transform, because the question tells us specifically that it is based on Fourier transform. Now the Fourier transform of x1 of t into x2 of t would be 1 by 2 pi times the two forms given here, x1 of j omega, x2 of j omega. This is multiplication, please note. So that's 1 by 2 pi into this, and by looking we can tell that these two, that the multiplication of both will be conjugate symmetry. Think about it. If you multiply both of these waveforms, just club them together. If you club them together, you will see that they indeed are conjugate symmetric. They are symmetric. Each part, that is the left hand side and the right hand side, will be symmetric with each other, and that indicates now, because x1 of omega into x2 of omega, it's this portion over here, this portion is conjugate symmetry. Conjugate symmetric. Okay, you should know that just the waveforms by themselves, okay, I think, yeah, now it's in view. Okay, so just the waveforms by themselves, x1 omega and x2 omega by themselves separately, they are not conjugate symmetric, but if you club them both together, multiply them both together, you will notice that the waveforms are indeed conjugate symmetry. And because they are conjugate symmetry, its counterpart of x1t into x2t is also conjugate symmetry. And we noted that if it is conjugate symmetry, that means that it is real, which means that x1 of t times x2 of t is real. So we established this fact, x1 of t into x2 of t is real, and x1 of t and x2 of t separately are complex. So let's see which option. Here, option number C, x1 of t and x2 of t are complex, x1 of t into x2 of t is real. Well, I hope this quick analyzation of the forms, waveforms and the notes help.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.